Hello students, welcome back. Let's move on to the next topic from the chapter Carbon and its compound. The topic is properties of carbon compounds or properties of covalent compounds. Now overall this topic is not very important, so we're not going to spend a lot of time on this topic, and we'll quickly do two questions that probably might be asked in your board examination. So moving on to the first question. The question says, why carbon or covalent compounds have generally low melting and boiling points? So here you need to understand two things, that if you want to melt something, that means you have to convert from solid to liquid. And if you're converting a liquid into gas, we say that we are boiling. Now, what you have to do when you're going to heat a solid? You all know from your class 9 that solids have very strong intermolecular forces of attraction. That means if this is molecule number 1 and number 2, the force between 1 and 2 is very strong. But the spaces between the molecules is less. Right? As you move from solid to liquid, the intermolecular spaces increases and the intermolecular forces of attraction decreases. Right? Now this is liquid, and if I have to represent gases, gases have maximum intermolecular spaces and minimum intermolecular forces of attraction. Correct? Now if I have to convert solid into liquid, definitely I have to heat, and when I heat, I need to break this bond of attraction, intermolecular force of attraction. Similarly, if I have to convert a liquid into gases, I need to break this force of attraction. And how do I break this? By supplying heat. Now, if these forces are weak, definitely your boiling point will be less. Similarly, if in a solid this force is weak, then we say that that solid is going to have low melting point. Correct? So let me explain this again by taking an example of a covalent compound, and that covalent compound is water. Now these are water molecules. Water has the formula H2O. The center one bigger atom is oxygen and the smaller white one are hydrogen. So H2O. Now water has two covalent bond. Oxygen is bonded to this hydrogen and this hydrogen by covalent bond, right? They say that this covalent bond is very strong. Fine. Coming on to this one, again this is oxygen and these are hydrogen. Again oxygen here, hydrogen here, and henceforth. Now when we are going to boil water, we need to break these forces of attraction. This is one molecule, this is second molecule, so on. The forces between these two molecules are weak. Whereas in the molecule itself, these are strong covalent bonds. You're going to study later on in your higher classes that these are hydrogen bonding, etc. That we're going to leave right now. You need to understand that between the molecules, you have very weak intermolecular force of attraction. The name says intermolecular, between the molecules. So between two molecules, the forces are very weak, right? The same molecule has strong covalent bonds, but in order to melt or boil a compound, you need to look at these forces. Since covalent compounds have weak intermolecular forces of attraction, therefore they have generally low melting and boiling point. So students, if in case in your board examination you are asked why carbon or covalent compounds have generally low melting and boiling points, you do not have to give the explanation. You simply have to write down the answer, that covalent compounds have strong bonds within the molecule. Within means, look at this water molecule. Oxygen and hydrogen are held together by strong covalent bonds, but they have weak intermolecular forces of attraction. This force is weak. Fine. So you have to supply little heat and these forces break. The intermolecular space increases, intermolecular force of attraction decreases, and a solid converts into liquid or liquid converts into gases. And thus they have generally low melting and boiling points. Moving on to the next question. The next question is, why carbon or covalent compounds are generally poor conductors of electricity? Wherever I use the word generally, that means there are exceptions. Now, my dear students, you would have learned in your lower classes or in your previous chapters of chemistry that to conduct electricity, you require charge carriers. Now, these charge carriers can be electrons, free electrons that are not bonded, all right, or they can be ions. Covalent compounds neither have free electrons nor they have free ions, and hence are poor conductor of electricity. So if this is a question, what will be your answer? Covalent compounds generally do not have free electrons or ions. What are these free electrons or ions? They are charge carriers. So since there are no charge carriers, they are generally poor conductors of electricity. Now why did I say generally? Because there is an exception in terms of, let's say, graphite. There is an important question that why graphite is a good conductor of electricity. I'm going to take that question in the topic on allotropes of carbon. With this, we complete important questions from the topic properties of covalent compounds. Keep watching for the next question in the next video.